Hyperledger and Its Importance. Hyperledger. Hyperledger is an open source collaborative effort created to advance cross-industry blockchain technologies. It is a global collaboration hosted by the Linux Foundation, including leaders in finance, banking, Internet of Things, supply chains, manufacturing, and technology. It is a framework to create, deploy, and maintain blockchains for businesses that ensure accountability, transparency, and trust among business partners. As a result, Hyperledger makes business networks and transactions more efficient. Concept of Hyperledger. Now, before I tell what Hyperledger is, let me tell you what Hyperledger isn't. Hyperledger isn't a blockchain, a company, or a cryptocurrency. Hyperledger is a software used to create one's own personalized blockchain service. It is basically a project within the Linux Foundation, just like several other projects under them, which include Node.js, AllJoin, DroneCode, and Akumos. Since it is open source, people across the globe can come and help develop and grow the platform. Restrictions in public blockchain. With a goal in mind to develop an enterprise-based blockchain platform, developers started testing interactions between applications and secure blockchains and realized that public blockchains require each peer to validate transactions and run consensus. This is a major challenge when it comes to scalability. Moreover, the transaction confidentiality and privacy was also getting lost as every node in the network was receiving a copy of the ledger. Private and confidential contracts. Let's consider an example. A certain bank is giving better privileges to its premium customers, for instance, in credit cards. Thus, if I am a premium customer of the bank and have been banking with them for quite some time, then it will give me a better offer on credit cards or will give me a loan at discounted rates. These things are common in the banking world. However, if these banks start using public blockchains which have complete transparency, disparity like these will become evident. Moreover, there is an issue with regards to competition. All banks are competing with each other in order to create a better place for themselves in the market. Thus, they want their confidential information about transactions and other operations to stay completely confidential. This won't be possible in a public blockchain like Ethereum, which stores all smart contracts on public ledgers. This is where platforms like Hyperledger come into the picture, which permits permissioned and private transactions, and it is highly scalable as a platform. Solution to the restrictions. On Hyperledger Network, only parties directly related to the transaction deal are updated on the ledger, thus maintaining privacy and confidentiality. Hyperledger primarily leverages the concept of channels to ensure privacy and confidentiality. A channel is basically a virtual blockchain network which sits atop a physical blockchain network and has its own access rules. They employ their own mechanism for transaction ordering and thus ensure scalability, thereby permitting effective ordering along with the separation of data. In the above example, when John and Kat are conducting a transaction, a private channel between them serves as a method of interaction. The smart contract can thus be viewed by only these two parties, and the network's endorsement policy verifies their membership with the network to ensure privacy. Thus, the transaction is secured and private and confidential. Hyperledger Transaction. In the above example, John is initiating a transaction to send a message to Kat. Let's assume that we have a state in the ledger named as message, denoting the last message that had been sent and its store as a key value pair in peer of organization. Now, John has decided to send a new message to Kat and submit a request to the Node.js backend from the message dashboard. The Node.js SDK client takes this new proposed state and sends a proposal to all the endorsing peers of the organization as per the endorsing policy defined in the channel configuration as well as confiding to the membership services. This includes a proposal request to invoke the corresponding function described in the chain code. The message thus gets verified by the orderer and finally gets committed to the CouchDB, thus confirming the transaction. Linux family. Hyperledger is a part of the umbrella project under Linux Foundation, where a community of developers work on open source projects. Linux Foundation provides infrastructure, services, events, training, and financial resources for creating sustainable open source ecosystems. Linux Foundation is known for its open source projects. Hyperledger is a consortium of organizations. It's not a blockchain platform. With Hyperledger, there are different blockchain projects. The original code for these projects was submitted by various companies like IBM, Intel, etc. Linux then made these codes open source to invite the entire community to work together and contribute to the codes. The vision was to create an enterprise-level blockchain platform. Hyperledger Projects. Hyperledger Umbrella Strategy. Hyperledger nurtures a lot of blockchain frameworks and technologies under the umbrella strategy. Some of the well-known projects under Hyperledger are as follows. Sawtooth Lake. Hyperledger Sawtooth is a blockchain platform implementation which builds, deploys, and runs distributed ledgers. It is a modular platform which provides a digital record without a central authority or implementation. It is primarily used for supply chain networks. Fabric. Hyperledger Fabric's framework was contributed by IBM. Fabric works as a foundation for developing applications with a modular architecture. The framework utilizes container technology to host smart contracts, chain code, comprising the system's application logic. One of the examples where it is used is fishing industry to track the supply chain of fishes. Burrow. Hyperledger Burrow, hosted by the Linux Foundation, is a blockchain framework implementation. The framework was contributed by Monax and co-sponsored by Intel. Burrow is a permissioned smart contract application engine partially developed in accordance to the specifications of Ethereum Virtual Machine, EVM. It is used to run Ethereum smart contracts. Iroha. Hyperledger Iroha, hosted by the Linux Foundation, is another blockchain platform implementation. The framework was contributed by Soramitsu, Hitachi, NTT Data, and Kolu. Written in C++, Hyperledger Iroha incorporates a unique algorithm on chain-based Byzantine fault-tolerant consensus. It provides a small set of fast commands and queries covering most common operations for the digital asset and identity management. It can be used in mobile application organization. Indy. Hyperledger Indy is a distributed ledger and utility library built for decentralized identity. The distributed ledger provides tools, libraries, and reusable components to create and use independent digital identities based on blockchains. They are interoperable across administrative applications, domains, and any other silo. It is used as a decentralized identity database. Sawtooth. Hyperledger Sawtooth is a blockchain platform built for enterprise use where the design focuses on maintaining the safety of smart contracts and the ledgers are kept distributed. Sawtooth offers a simplified platform for blockchain application development by separating the application domain at the core system level. Application developers could opt for a language of their choice to write smart contracts logic. Following are some of the key features of Sawtooth: application layer in core system separation, parallel transaction execution, pluggable consensus algorithm, private networks with Sawtooth permissioning features, Ethereum contract compatible with Ceph, event system. Hyperledger Architecture. Hyperledger blockchain network participants. Following are the different participants within Hyperledger blockchain. Blockchain user. A blockchain user performs transaction on the network. The user can invoke a function from the chain code in order to send the instruction message to the underlying network, which can then process the transaction. Certificate authority. The certificate authority ensures that only certain restricted parties can be a part of the business network on Hyperledger. They access security certifications in order to determine the parties who have required privileges to be an actor on a network. Traditional database. It is a standard database which is used to store data. Traditional processing platform. It stores access to the logical code written, which is used to run the network as per the design. Blockchain development network. It operates the blockchain network, which enables the execution of smart contracts chain code, as well as various transactions that take place between the participants which are part of the network. Blockchain developer. A developer develops applications on the blockchain using chain code. Currently, Hyperledger Fabric supports Node.js, Java, and Golang languages to write such chain codes. Regulator. Regulator runs oversight to ensure that the platform is operating without any bias. Hyperledger Architecture. Following are three main components of Hyperledger. Membership service. It is a set of cryptographic materials, certificates, that defines organization by itself. Every peer and orderer needs this type of certificate. This certificate has some common property by which we decide whether the peer and the orderer belongs to the same organization or not. A peer, which is a part of the same MSP, can communicate with each other. A peer from other organizations cannot be allowed to communicate with each other. Blockchain and transaction layer. This layer constitutes the core code of the blockchain. It comprises of consensus algorithm, which is required to make the final decision on the state of every transaction. It also contains the distributed ledger and ledger storage, which stores the entire history of the transactions and the last known states. Lastly, we have the P2P protocol, which is used for communication between different nodes on the network. Chain code. It is the logical programming layer which consists of the business logic required to run an operation on the Hyperledger. Permissioned blockchain and its consensus model. Permissioned blockchain maintains an access control layer and allows certain actions to be performed only by a few identifiable participants. It is also called private blockchain. Following are the properties specific to permissioned blockchains. It has legally accountable validators. It is suitable for off-chain assets. They can be used as an IT tool for settlement and clearing. Examples include Ripple, which determines roles for a select number of participants who can act as transaction validators on their network. Such blockchains are also popular among industry-level enterprises and businesses for which security, identity, and role definition are important. Permissioned versus permissionless blockchain. Let us see some differences between a permissioned and a permissionless blockchain. 1. In regards to access, a permissioned blockchain only allows pre-approved members to access the network and make transactions to it, whereas a permissionless blockchain allows anyone to be a part of the network as it is completely open and transparent. 2. Permissioned blockchain are faster than permissionless blockchain when it comes to performance, as they have less number of participants in the network. 3. Permissioned blockchain use different types of consensus algorithms like PBFT, proof of stake, and more. Usually, permissionless blockchains rely on proof of work. 4. The transaction cost in a permissioned blockchain is lower than that of a permissionless blockchain. 5. In regards to stability, permissioned blockchain are considered more stable compared to permissionless blockchains, as the former have a better governance due to known parties which are a part of the network. 6. In a permissionless blockchain, all participants have the same level of access, whereas a permissioned blockchain provides full access only to the members which are registered to be a part of the business network. 7. Permissionless blockchains work in a peer-to-peer fashion, relying solely on consensus algorithms to create a trusted environment. However, permissioned blockchains have trusted members as part of the network, which enhances the trust on the network. Consensus and its interaction with architectural layers. Consensus. Consensus is the process by which a network of nodes validates the block of transactions and provide a guaranteed ordering of transactions and validating those block of transactions that need to be committed to the ledger. Consensus must ensure the following in the network: confirms the correctness of all transactions in a proposed block according to endorsement and consensus policies, agrees on order and correctness and hence on the results of execution, depends on smart contract layer to verify correctness of an ordered set of transactions in a block. Hyperledger makes use of the permissioned voting-based consensus from the pool of the other consensus named the lottery-based consensus. Consensus properties. Consensus must satisfy two properties to guarantee agreement among nodes: safety and liveness. Safety means that each node is guaranteed the same sequence of inputs and results in the same output on each node. The algorithm must behave identical to a single node system that executes each transaction atomically one at a time. Liveness means that each non-faulty node will eventually receive every submitted transaction, assuming that communication does not fail. Activities performed to reach consensus. Hyperledger frameworks reach consensus by performing two activities: transaction ordering, transaction validation. By logically separating these activities, we ensure that any Hyperledger framework can work with any Hyperledger consensus module. The first step of the consensus process flow is receiving the transactions from the client application. Consensus depends on an ordering service to order transactions. Transaction order enables confidentiality of the transactions. It also increases the efficiency of the transactions. To validate transactions, consensus depends on the smart contract layer because it contains the business logic behind what makes a transaction valid. Transaction validation contains business logic to make the transaction valid. It also ensures the confirmation of policies and contracts specified for the transaction. Then, it also checks for syntax and logic errors. Consensus model for permissioned blockchain. Consensus in Hyperledger Fabric, as seen in the image above, is broken out into three phases: endorsement, ordering, and validation. Endorsement is driven by policy, e.g., M out of N signatures, upon which participants endorse a transaction. Ordering phase accepts the endorsed transactions and agrees to the order to be committed on the ledger. Validation takes a block of ordered transactions and validates the correctness of the results, including checking endorsement policy and double spending. As soon as a new transaction is created, it is sent to the endorsement peer to generate a read-write pair. The read-write pair from every endorser is then sent to the orderer, which orders the same and generates a block based on consensus. The ordered block is then sent to the validator to update the CouchDB with the most recent state. API and network topology in Hyperledger. API. It enables clients and applications to interface to the blockchains. Hyperledger supports the following types of APIs. Admin APIs. This class creates an administration connection to a Hyperledger Composer runtime. The connection can then be used to deploy business network definitions, Undeploy business network definitions. Update business network definitions. Send a ping message to the runtime to ensure it is running and correctly configured. Store a connection profile document in the connection profile store. Common APIs. They are used to obtain information about the connected networks. This information can include business network, metadata, enum declaration, and many more. Runtime APIs. These are used to perform all transaction operations like running a query, managing assets, and more. Network topology. Network topology is a technical infrastructure that provides smart contract services and ledger to applications. Listed below are the components of network topology. Ledger. A ledger consists of two distinct parts, a blockchain and the state database. Unlike other ledgers, blockchains are immutable. In contrast, the world state is a database containing the current value of the set of key value pairs that have been added, modified, or deleted by the set of validated and committed transactions in the blockchain. Smart contract. A smart contract is a code that is invoked by a client application external to the blockchain network. It manages access and modifications to a set of key value pairs in the world state. In Hyperledger Fabric, smart contracts are referred to as a chain code. Peer nodes. It is a network entity that maintains a ledger and runs chain code containers in order to perform read-write operations to the ledger. Peers are owned and maintained by members. Ordering service. It is a defined collective of nodes that orders transactions into a block. The ordering service exists independent of the peer processes and orders transactions on a first-come, first-served basis for all channels on the network. Channels. A channel is a private blockchain overlay which allows for data isolation and confidentiality. A channel-specific ledger is shared across the peers in the channel, and transacting parties must be properly authenticated to a channel in order to interact with it. Fabric certificate authorities. Hyperledger Fabric CA is the default certificate authority component which issues PKI-based certificates to network member organizations and their users. The CA issues one root certificate to each member and one enrollment certificate to each authorized user. Steps to create a Hyperledger network. Following steps should be followed to create a Hyperledger network. Step 1. Create a network. The network is created from the definition of the consortium, including its clients, peers, channels, and ordering service. The ordering service is the administration point for the network because it contains the configuration for the channel within the network. Step 2. Define a consortium. A consortium is comprised of two or more organizations on the network. Consortiums are defined by organizations that have a need for transacting business with one another, and they must agree to the policies that govern the network. Step 3. Create a channel for consortium. A channel is a means of communication used to connect the components of the network and/or the member client applications. Step 4. Join peers to channels. Peers are joined to channels by the organizations that own them, and there can be multiple peer nodes on channels within the network. Step 5. Install smart contracts. Smart contract chain code must be installed and instantiated on a peer in order for a client application to be able to invoke the smart contract. Step 6. Optimize the network. While there is no theoretical limit on how big a network can get, as the network grows, it is important to consider design choices that will help optimize network throughput, stability, and resilience. Step 7. Add another consortium definition. As consortia are defined and is added to the existing channel, we must update the channel configuration by sending a channel configuration update transaction to the ordering service. Step 8. Add a new channel. Organizations are what form and join channels, and channel configurations can be amended to add organizations as the network grows. When adding a new channel to the network, channel policies remain separate from other channels configured on the same network. Step 9. Add peer and join it to multiple channels. You can continue adding new peers and connect them to several channels within the network. Network topology. The diagram above shows a fabric network with the following configuration. There is a fabric network N with network policy NP1 and ordering service O. Channel C1 is governed by channel policy CP1. Channel C1 has been established by consortium RARB. Channel C1 is managed by ordering service O and peers P1 and P2, and client applications A1 and A2 have been granted permission to transact on C1. Client application A1 is owned by organization RA. Certificate authority CA1 serves organization RA. Peer P2 maintains ledger L1 associated with channel C1 and L2 associated with C2. Peer P2 makes use of chain code S4 and S5. The orderer nodes of ordering service O are owned by organization RD.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.